training session. We're back again in the second session of this user training for HPC at IIT Mandi. I was asking, does anyone have a question regarding the session we had in the morning? Good. So I'll just download the presentation and then open it and share with you. The network seems to be a bit sluggish in the academic area. So that is the reason for delay. Right, I'm back again. I've moved to my phone network now. Hopefully, should be all right now. You should be able to see my screen now. Right, I'm sure you can see the screen now. Yeah. So we talked about job submission. So we'll start with the next section, which is on troubleshooting. So there are many times you'll face issues, you'll face problems, and you'll want to troubleshoot them. So that's the point of discussion, topic of discussion. Typical troubles that you will face are: one, the job does not run. The other is job runs but stops immediately. So that will happen. That as soon as it enters leaves the queue and enters the compute node, it will immediately stop. The other is the job ran, but no output obtained back in WD. So that was one of the issues I just showed you earlier in the morning session, that the output file did not get copied. So that we recreated, and it could be any job crashing because of some issue. Okay. I'll always suggest that you troubleshoot yourself before sending an email, shooting an email to hpc@iitmandi.ac.in, because whenever we receive an email, we typically check if the cluster is working fine. So we have a standard list of checks. If that is the case, then we just forget about the email in most cases, because that is an issue that you might be facing because of some code issue rather than an HPC issue. Okay. I mean, what can you do? So when you get used to problem solving, you'll have a certain list of checks that you'll be doing yourself. But typically what we suggest is to check the queue. Have you sent the job to the right queue? What is the status of the queue if the job is not getting into the queue, for example, for a long time? It could be the case that there are lots of jobs in the queue. So if you do a queue start and with the -q command, you will get what's happening with the queues and how many jobs are being queued. So you are next in line. So it could be that reason. The next is feasible resource requirement. So I didn't show you. Maybe let's open the HPC website again. Right. So on the website, let's go to the scripts, list of scripts. So let's see this second script. So here what you have is n CPUs. Okay. So what that means is the number of cores you require. So for a parallel job, you'll have to tell how many cores you would want to reserve for yourself, and the job will then expand to that many number of cores. So you will in the job, when you launch it, the executable, then you have to specify that you need 8. You need to split the job into 8 parallel parts, and then the job will run parallelly on those 8 nodes. You reserve 8 nodes, and then move accordingly. So just check if you have, if you put 8,000 here, then your job will sit in the queue forever, because we don't have any hardware that matches this criteria. So it just keeps waiting for some hardware to become available sometime so that your job can go into queue. Okay, just check that again and make sure that indeed it is feasible to get that many resources. It could be again with the in sense of memory. There is a command for memory as well. Then if you have asked for 200 instead of 64 gigabyte, you ask for 64 terabyte. Then that's a mistake on your side, but then it will sit forever waiting for that 64 terabyte memory node. Okay. So just check the PBS script as well to make sure that that could be the reason the job has been sitting in the queue forever. Yes, Arjun, you have a question?
Yes, sir. Some of the resources I found in internet, the NCPU's number directly refer to the number of threads rather than number of cores. So do we have any distinction like that?
Right. So right now we don't worry about it, because as I said that we can only do multi-core jobs, not multi-node jobs. So your program will ask for 8 threads, and the best we can do is we can do 8 cores on a given node. This node as in physical node. We'll take 8 cores out of it and give it to you out of those 24 cores it has. So yeah, NCPU equal to 8 is 8 threads, and then your scheduler will give you 8 cores on a given node. You can actually, there is a way to specify clearly that you need 2 processors and 8 cores on each processor, something like that. You can do that as well.
Okay, sir. Thank you.
And you can always play around with these things and see what happens. If you give 5 here, then the scheduler might say that the code is running on, and it says N13, N14, N15. So that means it's trying to give you multiple compute nodes at the same time. Okay, so feel free to play around with these on day queues and see what happens, just to get comfortable with this environment. Right, so moving on. What else could be an issue that could be causing the code to crash? So code or input files needed by the code available at the correct path. So yeah, so it sometimes happens that we are running the script file from our home directory, whereas the input files that are required or the code that needs to run is actually there in WD or some folder of home. So it cannot find it. So rather than looking at the error that the standard error, the .e file that got generated saying that could not find this code, we have a tendency to say that HPC is not working. So HPC is not working, then probably not working. It's shut down, or it won't half work unless there is a hard drive issue, which do happen sometimes. But in that case, you won't get the error. You will get some other error, which is a endpoint not connected and so on. So if your error file says that some file not found, then it means that either the file is not there or you have given a wrong path. So do check that. And it's always good to, if you're doing some complicated stuff in a file somewhere, it's always good that I always have that test directory which has one standard Python file kept in my home. I always try to rerun that, because that ran properly, right? So that means that that is my standard check. Check it. If it runs fine, then HPC is running fine. There's some problem that I have done in my code. Okay, so do have that standard check in your home or somewhere, short test case that you can use as a control test. Make sure you're not exceeding the space in home or WD. So if that is the case, then it could give you some error that if you're trying to create a output file which is very large, it will not let you write it in the file system because you already are above your specified limit. The other thing that happens is, so I told you that every node has a local drive in it, so that if you generate large files, there is a lot of time it takes for the file transfer to happen between your WD file system and the node. So when your node is generating file while the code is running, it will try to generate file locally, and then towards the end of the execution of the code, it will copy the files. So it stores locally in a scratch. So let me log into the cluster and show that to you. Can't do that, right? Because I'm out of college network. I'm on my phone network. Well, give me a minute. Let me try to log into the college network. Cool. So hopefully it allows me to use both networks at the same time. Great. Can somebody please confirm if you can hear me? Because I'm using 2 networks at the same time.
Yes, sir.
Thanks, Arjun. Right. So where were we? Right, scratch, yes. So there is a local scratch on each node. So let's say we have by the way, sometimes the institute network also fluctuates, okay, like it's doing today. So in that case, I mean, it may only be happening in our in my building in A1. But that again, I keep hearing that HPC cluster has a problem. It's not the cluster; it's probably your hostel network that could be an issue, which is causing this slow login to the head node. Okay, so just be a bit patient there. But if you run jobs, everything happens low. So once the job goes into the compute node, then there is nothing that is going to be slow. Things will go as fast as they can because there's no network involved there externally. Right. So let's log into some node. Ah, really slow. It's good that we are seeing all these things because they do happen quite a lot. I do have a local network connection, but I can't connect to the HPC cluster. We'll come back to it. Okay, so I'll show you how the scratch files are organized, but let's make use of time here. Right, full screen. Okay, so we'll show you how the scratch looks. You can also check the error and output files, which I actually showed you in the morning. The output file actually, if there is an error, then a .e file also gets generated. In the morning, the code did not have an error; it just ran fine. It had an output, so only one file was generated. And if nothing works, then you can always use Google to understand available. Many codes will have their own log files, so some of the output will go into that log file rather than coming to the standard output, which gets into the .o file. So make sure you check those log files as well. They might be bulky, there's lots of stuff in them, but it's worth the read, because I will not read. I mean, administrators of HPC will never read those files for you. It's your work. Okay, this I have discussed. So the scope of HPC administration should be clear. So you're not paying the administration to solve things for you, because it's just me and two other people. So our job is to mostly make sure that the cluster is running fine. We give you the hardware which is working fine. It's your job to figure out how to get your codes running. If you have errors, then you sort it out yourself. The sooner we realize that, the happier we are in the future, and don't blame the HPC administrator for not solving my problem. Yeah? We solve our problems ourselves. That is the reason we are having these trainings. But you can always email them to us, and then if we have time, we direct you to the right place to learn best practices. Okay, some good practices as an HPC user. Make sure you clean the scratch. Again, I'll check again if it's back up. Yes, seems to be. No. I'll keep it on the other screen. As soon as we log in, I'll let you know. Okay, so clean Scratch. If you generate more junk, then make sure you clean it yourselves. Usually what happens is the local nodes, the Scratch drive will create a folder with your name on it. Okay. Typically, it's supposed to be done automatic, but we don't do it because many times what happens is for some reason, if your code crashes and the data was not able to copy itself to your WD, then you lose the data. So all the local results are stored there. So if they have copied successfully, and this is particularly for people who use Gaussian. So Gaussian code generates very large files, and these files, once the code execution is over, they get copied to your WD, where you want them to copy to. But they also remain on the local node. So after some time, you will see that if you try to run a code, and typically Gaussian codes will go to certain nodes because of the queues, your code will not run. It will say that some drive full, and that means basically that the Scratch drive on the local node is full. So what you do is you try to log into the local node that your code is trying to go to, check the Scratch, and once I can log in, I'll show you how to check it, and then see if there is any able to log in. Yeah, let's see if we can quickly do it. So I was able to log in, then I SSH to N18. That's one local node. Okay. So let's see if there is so there is a /scr folder in of the connection again. Very frustrating. So this /scr is a folder available on each node, and that is where the Scratch goes. So just check that folder. You will see that sometimes that there is a folder with your name, which is taking a lot of space, and you simply have to delete it. And you can delete it yourself because you were the one who created it. So you have the access to delete that as well. If this is somebody else's folder, then you can't do it. Then you let me know or let administration of HPC know. If not, then you can always let that person know as well, because you'll probably be knowing that person because that person works in uses Gaussian or a similar HPC code, right? So there are ways to get things done faster. But if you tell us that no, it seems that the Scratch in N18 is full, then I can sort it out much quickly because you already have troubleshooted the problem yourself. Then we can take an action very quickly. Okay. The other good practice is to checkpoint. Now, if it's a standard code that you have found on the internet, an open source, they will probably have checkpointing in it. So what that means is as you are generating more intermediate results, rather than not saving them and moving to the next iteration of the code, it actually dumps intermediate data into files. And how often would it dump? That depends on your settings in the code. Okay, so if I'm running a job, let's say, which tends to run for 20 days, I would want to dump it, 4 times every day, typically. So I'll have 80 files. If I really have big files, then what I do is I dump a new file and I delete the previous one after creating a new dump. Or I have 2 times t and t minus 1 and t minus 2 I delete. So that way I'll always have the current in the previous dump. And if the code crashes or something happens, then I can always restart it from the latest version of the or latest iteration of the run. It is true for any molecular dynamic system or computational mechanics. All these will have a serial script, a serial algorithm in terms of time, and then you'll be able to save dump data at intermediate steps. Okay, so please, if you're writing a code, then make sure checkpointing is a feature that you are creating to, and you allow to, the code to dump data and then read from that latest backup. And again, if you're using an open source code, I'm very, very sure that option will be there. If it is not there, then that code is not worth using at all. That's a very standard programming strategy to create checkpoints for heavy duty nodes. Well, other good practices are to back up your data regularly. Okay, so HPC again is a facility where we give you computing power. We don't give you storage space. It's not a OneDrive or IIT Mandi Cloud or Google Drive or anything. It is simply a computing facility. Okay? Although it's not that we randomly delete your data every so often, but if you run a code, you got results, I'll suggest you copy it back to your local hard drive. I mean, if it's 10 terabyte, then it's worth buying 50 terabyte hard drive or something locally. Many people, what they do is, if the storage is large, then they buy their own hard drives. I mean, if they have computing nodes from their group sponsored into the HPC, and we'll put those drives into your private nodes. So what happens is, you can always back up the WD data that you're generating intermittently into your private hard drives, which are actually stationed in the HPC cluster only. So that ways, your data is getting stored in a drive that is yours. So you will not feel helpless if that data is not available because of a hard drive crash. Okay, so we have a parallel file system which has more than 20 hard drives where the data is distributed. So if you understand probability and reliability, then you will know that there are as you increase the number of hard drives in the cluster, the chances of at least one going bad in a given amount of time is increasing very steeply. Again, to give you the maximum amount of data you can store, we don't create backups, because right now we are not into multiple backups of the data, because we're not a data storage facility. Okay, so given the hard drive space we have, we try to give everybody maximum space rather than multiple copies of the same files. So that way, if one of the drive goes bad, which has happened in the past, then whatever data was on that drive gets lost. So if your folder has 10 files and suddenly you see that after 10 days, 2 files are missing, that could be because those 2 files in the parallel file system were on that hard drive which crashed. Okay, so make it a practice to back up your data regularly. And in fact, towards the end, I'll show you that it's not that difficult. You can actually write a script on your local machine which automatically runs it every midnight and backs up the data, and it won't have to copy 20 terabyte again. So if you generate 500 gigabytes new, then only those new files will get copied rather than the whole 20 terabyte getting copied back to your local drive. So it's called rsync, where you can copy you can synchronize the change rather than copying the whole folder structure again. We'll talk about it. It's worth spending time writing those copy or backup scripts as well. Okay. I have one more time to see if we can log into the cluster. Does anyone have a question? Okay. I was able to log in. I am on SSH N18, and then I could go to /scr, and then there's a folder called user, and I'm gone again. Okay. Give me a second. Huh? Let me talk to the IT and check if there's a network problem right now. Yes, seems like it was an issue with my network being used on the Wi-Fi card. Okay. Well, can somebody please confirm on chat if you can see the terminal with the HPC login? Thank you, Vivek. Thank you very much, everyone. So yes, so we have logged into the SCR now. That's a scratch on N18, for example. And then if I do a ls minus L, oh, Is there anyone who's also facing issues with the institute network in South Campus?
Yes, sir. There's plenty of issues here. It's fluctuating like anything. The
Uh,
morning.
that could be the reason. Okay, so we have to live with that. That is beyond our control. So we'll keep trying. Okay, so I will share my screen again with you guys. Right. So I was able to log into the node N18, and then I went to the scratch, which is SCR, and then I do an ls minus l. So you can see that we have lots of stuff in this scratch here on N18. So that means that this scratch is available. And if I do a top, which is to check what codes are running, there's no code running right now. So these are scratches from the earlier executions. Okay? Which is fine. I mean, I'm not blaming these people for not copying their files, but ultimately what will happen is that this hard drive will get full. So if I do a du minus h, then it probably will tell us that 302 gigabytes is being used in this hard drive currently because of scratch. So I can safely delete these files. Well, I can't do it because right. Okay, so back again. This will keep happening, huh? The network's fluctuating a lot in A1 building at least. Right. So is that clear? The scratch. In fact, if I go to the head node, which is N199, okay, it's not showing. So what happens is scratch also gets, you can mount it on the head node and work with that. It's not showing that right now. Let's see if this works. Yeah. Okay, so it's an auto mount. Okay, so now we can see that. So now I can see N18 is showing on head node. So slash SCR in head node. So slash SCR basically is a network um, folder which is available throughout the cluster. I can do an CDN19. Probably that will come up as well. Okay, so now if I do, it shows N18 and N19 in the current scratch. Yes, I can do CDN19 and then I can take that. So I actually don't need to go locally to that node because scratch is a drive which can be mounted anywhere. Okay. So this is an auto mount. So basically what happens is it will not show you in ls. So N20 is not showing, but if I do a CD N20, then it will come up and I lost the network. Well, not a very pretty recording to share on the website, this intermittent recordings. Anyways, so I think I've made the point clear about Scratch. Any questions about it? We'll have to move on. We're running out of time now. Right. So what is the order of problem solving? Well, first you consult with yourself with the help of internet. Okay, so read the log files, read the error files, try to think about what's happening, go through all the problem solving strategies, and then check the internet for any error problems, error messages you are getting. Whatever's happening, try to figure it out yourself. Okay, try to sort out the problem with yourself. If it doesn't work out, check with your lab mates. I'm quite sure that one or more will be using a similar kind of system. So it's much easier to ask them over phone and ask them to recreate a similar problem and see if HPC is behaving the same way as it does for you. If they can run it, then most probably it's to do with something that you have recently changed on your HPC. Sometimes in our own account, we delete some bash file or change some bash RC file, and then it creates havoc in the results. Consult with other HPC users if it doesn't work with the lab mates. In this group, we have quite a few. You will end up figuring out who else is using HPC for running similar kind of codes or other codes. Check with them. You can always email at HPC users and say that this is the problem I'm facing. Is there anyone else who is facing the similar issue? And whenever you send an email or message a group, try to include as much information as possible. If you say there is a problem, please figure it out, nobody will ever read that email. In most cases, they'll simply press delete. So if you say that this is the problem I faced, these are the script files and the error files and log files, and I think this could be an issue, but I'm not quite sure about it. I checked on Google and all these things. So it seems that people will be able to help you in a much better way if you provide a lot of information. If it doesn't work out, then you consult your supervisor. Many people are scared to talk to their supervisors about HPC. See, in a similar way, if you were to do an experiment and things were not going the way they were going, you would talk to the supervisor, right? Similar is for the HPC as well. You ask them, and it is their job to make sure that they help you get trained with the HPC skills and facility. So there are CDAC runs many courses on HPC, how to use HPC, write programs, and so on. So they will figure out a way to get you trained in that. And if everything fails, then you contact the HPC administrator. Okay, so this, if you follow this order, then your problem will get sorted the most and in the most quickest way. All right, so let's move on to installing software. Many people actually were waiting for this step. So as I said earlier, that we don't install any new software. So there's something called bare metal installation. So what that means is that the software is installed on the HPC cluster by the administrators, and you will run it. That's called bare metal on the cluster. That only happened earlier. There could be some software that's already there because it was installed long ago when containerization was not enabled on the cluster. But now, because the number of users have increased, the type of users have increased. So because of to cater the heterogeneity and help everyone as quickly as possible, we spent a lot of time to enable containerization on the cluster. So what that means is you can develop your own containers locally. For example, if you have a Linux, HPC is a CentOS based cluster, but let's say you have a software which can easily be installed on an Ubuntu machine. Sudo apt-get install something. It's available in the repository, but you can't do it on the cluster because you don't have root privileges, or the cluster is not Ubuntu based. You can actually develop a container for this locally in less than 15 minutes, and you copy the container on the HPC and it will run as it is. Doesn't matter if the HPC is CentOS based, it will run your container which is based on Ubuntu. Okay, the HPC does not care what the container base OS is, it will run it. Okay, so please, we'll talk about it. We'll talk about developing containers, but that's a very useful thing, and it's actually it gives you more freedom to work with your own stuff rather than depending on somebody else. Okay, there's another way which people do is to install software in WD. It is allowed. You can copy anything on the WD. It's your working directory, but it's complicated to do that. It's also complex. It involves lots of other, there may be dependencies. So if you need some software, it may be dependent on GCC and all these things. Some may be available on the cluster, some may not be. So you have to install all those intermediate or dependency software as well. So that creates, I mean, you need to be an expert user of Linux. Only then you can install stuff on the WD by yourself. But it is theoretically possible. Okay, so nowadays with the availability of containers, nobody does that. People develop their own containers. And people also use virtual environment where they create some apologies again for the nth time. So without wasting much time, let's move on to Singularity containerization. Unless anybody has a question, I'm happy to answer that. So if you go to software section on the HPC website, then it says, please note that we do not take requests for software installation on the cluster. We encourage you to develop your own Singularity containers, which is similar to Docker's, on your local machine and use them to launch your software on the HPC cluster. Please see the documentation for further details. So before I start with this, let's go back to our cluster and then show you. Well, try to log in first. Yeah, I'm sorry for that. We're waiting for somebody to help with our internet here. So just wait for 5 minutes. We'll start again in 5 minutes. Thank you. Right. Let's start again. Okay, we'll try to run this training without the institute network. Yeah, I can at least show you how to create containers without the institute network connection. So hopefully, share my screen with you. Right. So in general, the first thing to check is what version of Singularity is available on the HPC cluster. Um, in a folder called /optsoft, we have a folder called share, which is an auto mount. So it gets mounted when you require it. I'll keep trying this, and once we connect to it, I'll show you the version of the Singularity we have. So the reason is that if you create a container on your local machine in a version of Singularity which is greater than the one that we have installed, then that backward compatibility may not be there. Okay, so I try to create the container in a similar version or a version before that, so that the installed version of Singularity in the cluster will be backward compatible. Okay. Right. So let's look at the Singularity documentation again. So you can see that there's plenty of stuff available here, but what we're interested in is to how to make Singularity containers. Okay, so the installation steps you can figure out yourself. If I check on my local machine, if I have Singularity, if I just type Singularity, something happens. Okay, so that means I was able to install Singularity some time ago. So it's already there. But if you don't have it, then you can always follow these steps and install Singularity. And it will also allow you to install Singularity of a given version. Okay, so please check it. It allows you to, it helps you to do that on any Linux machine. Let's see what version we have just for check. So I can write Singularity with a -- version option. It says it's got 3.7.0. I don't remember what the cluster has, but let us assume that this version that we have is less than equal to the version of the container that's available on the cluster. So we proceed. I'll follow the steps available on the Singularity website so that you can follow it. Just a second. I can also write which Singularity. It will tell me from where is it running it. Okay, so this is the Singularity software that's installed in user local bin Singularity. Right. Okay, so let's go to the next step, overview of Singularity interface. Okay, so this will tell you what sort of options are available and what sort of commands you can build a container, you can execute a command within a container, you can shell into the container. So container is like an operating system that's sitting in a file. So if you shell into it, then basically you are into that operating system. So now whatever you do is going to be happening inside that OS, which is sitting inside the file. I'll show you. And some other options are available. So now images are available. So you can actually download Docker images as well and run them. So there is a container library and or Docker Hub. So let's go to Docker Hub and then see what sort of standard containers are available. I think we'll have to log into it. Okay, so we see that lots of containers are available. So let's say I want to search for some software, which is, let's say ANSYS. Maybe ANSYS is available. There. 16.04 is available. Ubuntu, let's say, no, for some reason my software only runs on Ubuntu 16.04. Well, quite a few containers are available. Okay, so you can use one of those rather than developing one from scratch. So you can do a singularity pull like you do in Git, singularity pull, and then you give the path of the container. So if you click container, that should actually, just a second. Yeah, okay. So if I click on, let's say, one of these, it should hopefully show us. Yeah. So you see that it tells you that you run this command and this will automatically download the container on your local machine. Okay, I won't do it now because this is 335 megabytes. So it will take some time on and it will eat away all my phone network. So I won't do it. I'll try to pick up something which is much lighter than that. But anyways, it's possible, as you can see. Okay. So different versions are available. So for example, Ubuntu is available. So if library // Ubuntu, so that basically will bring the latest version of Ubuntu into your computer. Okay. So the first step is to start with some base OS. In my test case that I have thought for this discussion, we'll use an Ubuntu container to start with. Okay. So let's find an Ubuntu container. Let's Google. Okay, so this Ubuntu is a container. So Docker is also allowed. I mean, we can download from Docker also. It will work. Singularity works with Docker. And then I can have, by default, it takes the latest version of Ubuntu, whatever that is, depending on, and you can see that the size is quite low. So we can work with that on a phone network. Then there are other versions that people may have, 2104, 2204. It's very easy to move to different versions. So let's say I would want to, let's look for an older version. We have 1804. Well, let's go for 1804. Okay. So this is Ubuntu 18.04. So we'll use the same way like they have suggested here. Let's clean this a bit. Okay. We'll say singularity full, and then we'll say Docker Ubuntu 18.04. Sorry, spelling. It starts automatically. It's started to convert something into some format and starting to build it. It takes some time. Phone network is a bit slow in that sense. So I can see it's copying. It's that easy. I mean, simply have to write docker / / Ubuntu 18.04. And you can always go to this site and search for whichever version you want. But I was happy with this version. And we just need a base OS to start with, and then we can do stuff with it. It'll take some time and let it take time. Right now I'm using a phone network. Sometimes if you're using the internet college network, then you'll have to set up the proxy on the shell. Only then it will allow it to copy stuff. So you can always export HTTP proxy and HTTPS proxy. So these things you can figure out with the help of IT. Okay, so this has created an Ubuntu 18.04.sif. So that is 25 megabytes big OS, and it is actually an OS. I can actually do Singularity, sorry, shell into this. So then what it has done now is it has gone inside the Ubuntu 18.04. So if I do an ls now, well, by default it will map the same home into that. But if I do a slash and let's say cd etc, so all these files that I have in cd etc, they're actually the files inside the container, not inside my local machine. I can actually show you. If I do a cd etc on my local machine, then it has lots of stuff here, but this one only has a few files. Okay, any questions? So let's use the lsb release command and then see what we get. It's not there. Let's try it here. So on my local machine, it's saying that it's Ubuntu 20.04 LTS, but on this one where I've got a very minimal kind of OS, this command is not even installed, so I can't run it. Okay, if I do a vim, it's not installed. But if I go onto my local machine, vim is installed. So what we see is that this bare minimum OS that we have installed is different. Just to show you that we are inside, we have shelled inside this 18.04 Ubuntu, which is different from what our actual computer has installed. And it's all text. I mean, there is no graphics installed as of now inside this local shell. So I can exit from it, and then it brings me back into my original home, and I can always shell into it again if I feel like. I am back into it. So that was step one, to download a version from Docker and shell into it. Now the next step is to be able to change it. Right now it's an SIF file which we can't modify. So what I'll do is now I will make from an SIF file, I'll make a sandbox. Typically, I would write these things on a slide, but I thought that I'll just speak it. So this is being recorded, so you can always make notes later if you want to. I'll share this recording. So the next step is to create a sandbox out of it. So what we do is we say Singularity build sandbox, and the sandbox is called let's call it this ubun. and it is being created from Ubuntu 18.04. If I do an ls minus l, now what you see is that it has this Ubuntu folder in it. It's a folder. So I can do a cd into this. It's like you have converted that SIF file into a folder. So the good thing about making it into a folder is that now I can go into it, change files and so on. Earlier, if I tried that, it won't allow me. Okay, I can check. It's a 69 megabyte folder, whereas the SIF file was slightly smaller than that. Um, so 25 megabyte. Okay, well, not slightly smaller, much smaller. So this SIF file is compressed. So typically, the strategy we follow is. So the strategy we follow is that we download we download the image from Docker, bare minimum. We convert that to a sandbox. So the sandbox is like a box of sand. So you can put more sand into it, take sand out of it. So it's an expanded version. So you make a sandbox, which is a folder out of it. You make changes to the sandbox, and then make an SIF file again finally. And then you can move around that SIF file. Just a 25 megabyte file in this case, but it will grow as you put more stuff into it. Okay. Good. So I've been told that the network is in this building has been restarted. So let's try that. It's not that stable yet. Right. Anyways, we can carry on with this. Okay. Now what we want to do is we want to make changes into it. This Ubuntu. So what we do is, and now I'm on my local machine, not on the HPC, right? So this I have complete access to the local machine. So I can do a sudo. I can do a sudo singularity, and then shell. I'm shelling into this Ubuntu sandbox now, but I'll say that it is writable. Just have to tell that it's writable, so it allows you to write it. The reason we do that is because containers by default will copy the privileges of the local user. So if I want to install something, I need to have root access to that local machine. Even though I'm installing inside the container, but for safety reasons, just to make sure you can't have a root access in the container and then make changes to the local machine illegally. So the container will have, I mean, you will have the same access in the container as you have in the local machine. So if I did a sudo here, now I can install stuff in the sandbox called Ubuntu. Okay. What do I want to do? Let's say I want to install. It's as simple as apt-get install Vim. Okay, or before that, I want to install apt-utils. Try something else. So all this is happening. Now it allows me. So let's say I'm able to install something. So it's installing the Vim editor now inside the container. So what I'll do is I will install something in it um, which I would want to use on the HPC. I'm just thinking of what to install here, which doesn't take too much time. So let's say let's try Python. Well, let's see if Python's available right now. If I write Python, this command is not available. So let's say well, this is a good exercise. Um, I want a version of Python that is not available on the compute nodes. Many people have this question that I would want to run Python 3.8 or 3.6, but that is not available on the compute node. So please install it for me. So rather, I would say that make a container for yourself. So let's do that. So let's install Python 3.6. It's yes. Let's try Python 3.6. It works. Okay. So I was able to install Python 3.6 on the container. Very good. So I can now exit Control D, and I am out of this Python. Okay, this was Python. Now I am out of the container. So what we did was we just recall the last command. So we did a sudo singularity shell writable ubun. So now we went to the ubun sandbox. We installed something and we came out of it. Okay. So now I will shell into it again, but this time not as a root, because on the cluster I won't have root privileges, right? I simply want to run something. So I can still go. I can still write Python 3.6. I can still print something, and it works. Okay. I can come out of this and I can come out of the container. So this is working fine. So basically what we have is we have this sandbox called Ubuntu. Now I would want to make an SIF file again from the sandbox. Okay. So what we do is we say sudo singularity build, and then I have to give an SIF name. So let's say new.sif. Let's call it, it's the one which has Python in it and Ubuntu, and it comes from this Ubuntu. What I'm doing now is I'm building an SIF from the sandbox. Well, it's done. So you can see that if I do a human readable ls, then this Ubuntu Python is 74 megabytes in size, because we did some installation of Vim and Python and so on. We updated some repository as well, so it's bigger in size, but that's okay. It's just one file. Now I can go to a singularity just to check shell into Ubuntu Python. I'm inside the container now. I can write Python 3.6. I can check if my Python 3.6 installation is working. It's working. It's Python is working there. I can come out of. So now I was able to access the Python installed inside this cluster. You can't shell into it. That is not allowed. All you can do is you have to run Python. So typically, what you want to write in the in your previous script is some Python 3.6. How do you and the command that you would want to sorry I thought you can hear me, right? Just checking that. Oh, thank you. Okay, so we can use the SIF file. Let's try that. Let's clear things. Phone network is also becoming a bit dodgy. Right, so we want to use this file. So I'll say singularity execute. I want to execute the command from a container which is Ubuntu Python.sif, and the command that I want to execute is Python 3.6. Well, then you will need a py file, right? But that's good. So what I can do is let's delete that. So let's create a py file in the local folder, which is on my local machine, that I will later copy to the HPC. Test python.py. I've created a new file called test_python, which says just print something. If I do a local on my local machine, Python 3.6, it's not even there. But I would specifically want to run it in Python 3.6. Now you see that if I try to install something on my local machine, something breaks down and then something else will stop running. It happens a lot. So that is where also containers become useful, not just for HPC, but for your local machine as well. So rather than installing Python 3.6 on my local machine, I just made a container which has 3.6. So I can write singularity execute. And then I want to run Python 3.6, and the script I want to run is test Python. It works. Okay. So what it did was it launched Python 3.6 from inside the container with the help of singularity execute command. So Python 3.6 was not in my local machine. It was there inside this containerized operating system, which is 18.04 based. And it ran a script which is there in my local folder. And that is exactly what you would do on the HPC. You would copy this file there, and in your script, rather than saying simply Python 3.6 test Python, which will not run because your compute node will not have Python 3.6, you simply put these things before your Python 3.6 command in your in your job script file, the PBS script that we discussed in the morning. And make sure you give the correct path to this, This could be anywhere. I mean, this could be in WD. So in fact, I can make a folder and I can copy my, let's say, I can move my test Python script, or rather I would move my into the test folder. Okay. And I can also create a directory called backup, and I will move my Ubuntu folder to backup, and also move my initial 1804.sif into backup, because I really, I mean, let's not delete it. Maybe I would want to make something else out of it, and I would rename my test folder as Singularity image. Okay. Now, if I want to give a command, Singularity exec, and all this, it will have a problem because it could not find Ubuntu Python. So I have to change the path because now it is inside Singularity image / Ubuntu Python. And now if I run it, it runs. Okay, so I could explain this to you in less than 20 minutes, starting from scratch. So imagine if you get used to it, then how easy and quickly you can build containers yourself. And if I want to, not just HPC again, if I want to travel with a hard drive which has all different software and Ubuntu version and everything, they're all different files. That's it. So I can actually start. I can. That is what I do. I have a laptop, which is a bare minimum laptop, because so that it's fast. I have some basic stuff and Singularity installed. And whenever I want to run a software, we have a group software for CFT, which is quite huge. So I have a container of 4 gigabytes in size. I simply put a pen drive, copy that, and then run some code. And there's no need to install 4 gigabytes of stuff which has multiple dependencies and so on, which messes up my whole system. That's a software installation of feature. If I want to share something with a friend or a student, so rather than explaining it to them how to install the software and they will take months and months to do it, I'll just give an SIF file to them. And with the SIF file, they can literally just run the software with this Singularity command. Let me show you. Well, not in this one. So recently installed the machine. So I used to have a folder called containers, which has different containers or different types. So even ANSYS is installed in a container. And I can use those container to simply launch ANSYS rather than actually installing it on a machine, because ANSYS installation on a Ubuntu machine or a Linux machine is extremely complicated. But since I did it once, I can launch ANSYS, and even with graphics. I mean, it's not just text-based. If I go into that, I can launch ANSYS with graphics, and it will run completely fine on my local machine. So HPC aside, I mean, you can also use containers on your local machine without the requirement to install software on the local machine, which can mess up your system because of dependencies. Right. So any questions on Singularity containers? Do go through these instructions on Singularity. It's very nice. They will explain you with a step-by-step approach. They also have advanced features where rather than sharing a Singularity file, you can share a list. So the list of things I did, I can create a text file out of it, and then you can launch that text file, and it will automatically follow those instructions. The first step will be to go to Docker and get 1804 Ubuntu. From there, it makes a sandbox. From there, it installs Python 3.6 and so on, and makes an SIF. So all this can be automated into a script of Singularity, and then you can share only that script file, which is a couple of lines of text. It's up to you if you want to share that, or you can share the SIF file as well. All right. Questions, please. Good. So it seems that that was easy to understand. Let's share the presentation again. Okay. So talked about Singularity now. I told you what containers are, how to make them, test on a local machine, porting it to another machine. We didn't do it. Launching on the HPC, we didn't do it, but I showed you in principle what to do. So it should be clear. Some advanced ideas which I will not discuss, but it's for you to learn if you would want to. So if you're writing your own codes, you are allowed to compile them on the head node. Okay. Sometimes on the head node, we have some extra compilers installed in case you would want to do it. You don't need to go to a compute node to compile. But if your compilation process is extremely heavy, I'll suggest you do it on the compute node. But again, I mean, with the containers and all, who does that anymore? And containers have tested, they are almost as fast as bare metal installation. Some people think that, with the containers, you are installing stuff inside a file, so it won't be as fast as installing things on the HPC. That's not the case. I mean, they have been optimized, so they're quite fast, almost as fast as bare metal installation. Bash scripting, I mean, if you want to learn more, it's worth spending time on that. Scaling analysis, as and when if you are writing your own code, parallelizing it, even if you're using an open source code, it is worth as an exercise to do a scaling analysis. So on the x-axis, you have number of cores, and the y-axis, you have the wall time, and then you see what sort of speed up or what sort of decrease in time you get if you increase the number of cores. Is it linear? Is it flattening towards, so if my code for a given problem size would start flattening towards, let's say, 8 cores, then there is no point going beyond it, because if it flattens and it starts increasing after that. Okay. The reason is because there is some time spent in the cores communicating with each other. They have to do that. So that overhead due to communication between the cores can sometimes be higher than the time saving you get by parallelizing the problem. Okay, that depends on the size of the problem and the hardware and so on. So it's worth doing a scaling analysis rather than simply running it on 24 cores, because that's the maximum you can get. It may actually take more time to run on 24 cores than 12 cores. So do that scaling analysis, please. Okay. Git. So if you're writing your own code, again, if you're modifying codes, make it a habit to have an account on GitHub and keep committing and pushing stuff on Git as a branch of yours, so that the code remains updated, and if there is a hard drive crash on local machine and so on, then you don't lose on the scripts and codes. The last one is rsync. Do read about it. Rsync is a very powerful synchronization command. So what it does is, based on the last modified time of files, it will be able to synchronize. So if you're doing an rsync from the cluster to your local machine where you have a big hard drive installed, then you can write a bash script which does an rsync automatically at midnight. Okay, so you just leave your machine on all the time, and at 12 midnight it will do an rsync. So if you have generated 10 megabytes of data on the cluster, it will copy only that new 10 megabyte of data on your local machine. Other files will not be recopied because they are already the same as what they were on the cluster. Okay, so that helps you keep a backup regularly rather than doing it manually, which becomes frustrating, and then you stop doing it altogether, and then one fine day you lose data and feel bad about it. Okay? Let's not allow that. The weather's not very pleasant outside. I don't feel like taking my phone and giving you a virtual tour. So we'll do it some other time when you are back on the campus on a nice and sunny day. We'll show you the cluster facility. In any case, we'll move the facility to a new place in a couple of months. We'll have a much more advanced one. So we'll show you the facility some other time. Right. Expert groups. I don't see many people, but this is for you to talk about. So can one by one, well, if you feel comfortable, just tell us what you are working on, and tell us what field and what software you're using. So for me, I work in mechanics, particularly fluid mechanics, and the software I use is called Fluidity, which is an open source finite element based software for fluid flow modeling. Should I speak up names, or you can raise your hand and then I'll ask you to speak up if you feel comfortable. So do I assume that nobody wants to speak up? So this was a chance to make expert groups, but I guess you seem to be sorted. One last chance, if you would want to speak up, you can raise your hand. Yeah, Mr. Yogi, that's okay. You can write if you want. Okay, VASP code for DFT simulations. Okay, so others know that now. So if there's anyone else who is also doing the DFT and VASP, they can get in touch with you. Anybody else? That's okay. I mean, you can type if you want. QIIME2 software. Okay, never heard of that. What is it about? Okay. Metagenome analysis. Okay, very good. So, well, you don't have many people here. So, if there's anyone else who works on a similar software, they can also get in touch with you. Ishita, Quantum Espresso. Okay. Good. So you can also find people who are interested in this software particularly, or the field. I don't think so. This is a question regarding Windows. Yogi, I'm not sure if you can do that. As far as I am aware, it doesn't work on Windows. And as I said in the beginning, that if you are trying to use HPC cluster, move to Linux. If you really don't want to install Linux on your machine, you can always do a virtual machine with Linux on it. But you'll have to get rid of Windows one day if you want to survive with the cluster. Okay, so get used to it, get used to the commands, and with daily usage you will get comfortable with it. It's as powerful as Windows. Well, I would say it's much powerful, but that's a matter of opinion and experience. It has everything that you need. I made this presentation on Linux. I do all my documentation on Linux, all spreadsheeting on Linux, and then of course programming, etc., is also on Linux. Okay, thank you very much. So if there's nothing else, then we'll close this session. One last call for questions if anyone has any question about HPC or this training. Right, so thank you very much. We'll close this training now, and we'll make this recording available on the HPC website, which will be accessible to the local community of IIT Mandi. Thank you, everyone. Thank you. Have a nice day.